Hello, guys. We'll start exactly in 7 minutes. I just don't want anyone to miss out the initial few minutes. So let's wait for 7 more minutes. We'll start exactly at 8:10. Okay, so hello, everyone. I hope my voice is audible. Shivani, can you just confirm if it is audible?
Yeah, you're audible.
Okay. Yeah. Hello, everyone. This is Satyajit Pattnaik, and welcome to my channel. In case you are new to this channel, please subscribe the channel and hit the bell icon to get notified on my future video sessions, webinars, and all those things. Today we have with us Shivani. Shivani is a ML researcher focused mainly on novel state of art models in deep learning and machine learning. She has formerly also published novel research approach in ensemble model learnings. Apart from that, she is also a part of our data science community where she helps other fellow members and data science enthusiasts. And this is obviously not the first time she's a part of my webinar. I have recently started doing such live workshops and webinars and got several requests from many to conduct a dedicated session on exploratory data analysis. So that's why we are here. Initially, I shall be walking you through the concepts of EDA, what are the various data visualization techniques, which technique should be used in which scenario, what are univariate analysis, what are bivariate analysis, categorical analysis, numerical analysis. All these things we'll be covering. And then once we are done with the basic part, which will be around for 60 minutes, then I'll hand over the session to Shivani so that she can help you implement EDA on live use case. And as per her implementation, you can always take the same ideas and go back and take as an assignment and work on similar use cases as well. So EDA concepts are going to be very same. You have to implement those concepts in your use cases. So let's get quickly started on this. In case you have any questions in the middle of the session, you can post it as a comment or in the live chat, and I'll try to get back to you with the answers. If your questions are somehow missed, you can definitely reach out to me or Shivani directly. Links to our LinkedIn profiles are already shared in the description of this video. So I think we have enough people and we can start. Let's
Yeah, I
give one. Yeah. Yeah, Shivani, I'm sorry. Please introduce yourself as well into the crowd. I'm really sorry for that.
yeah, I was just saying it's even if you guys have doubts, I'll be looking over the live chats, so you can post them and I'll answer back whenever Satyajit is having his explanation sessions, and likewise he can take over when I'm explaining the code.
Yeah, yeah. Please introduce yourself as well so that people know more about you.
Okay, hi guys. I'm Shivani. So I have been on his channel before as well for the Keras tuner part, and the ANN video. You can go and check that out. It was real fun working with him. And apart from that, I'm currently working with a company, and it's sort of like I'm leading the data science team, and we're working on psychology, and we're trying to merge AI with that to understand how people behave and stuff like that. So yeah, that's interesting. Apart from that, it's really good to team up again with Satyajit and be here so that I could, just give back what I've learned so far. So
Okay,
yeah, thank you for having me here.
sure, Shivani. So let's get started, guys. We have a lot to cover in next 2 hours. So probably yes, recording will be available because it's YouTube live, so it will be there in my channel forever. But yeah, try to attend it live so that you get the most of it. Let's get started. Just let me know once you are able to see my screen. Shivani, is it visible?
Yep, it is.
Okay, so today's topic, as I already told, it's all about exploratory data analysis. I'll be talking about why is it important in the field of data science and analytics, because EDA is the core part. Without EDA, nothing is possible in the field of data science and analytics. Okay, so this is going to be the overall agenda for today's session. The first 1 hour is going to be very theoretical. Will not be able to show you some practical codes, but definitely whatever we will learn in the first 50-60 minutes, we are going to implement that in the next second hour. Okay, so this is the agenda. What is EDA? Why EDA is important? What is visualization and why data visualization is important? What are the various charts which are available in data visualization, be it seaborn chart or matplotlib charts, and we'll go through those things. What are the various steps involved in EDA? What is data sourcing, data cleaning? What is univariate, bivariate, and multivariate analysis with visualization? And what are derived metrics? So you will have a understanding on all these concepts once we get started. And of course the use case part. So this is the data science process which actually happens. You can see the reality. From reality is nothing but it all depends upon your use case. The first step is always data collection, right? When you are working for an MNC or any company where you already have a database of last 10 years, 15 years, 5 years, whatever it is, the first task is going to be data collection. And once we start collecting the data, after that we start processing the data. start making it to unstructured to structured data, start cleaning the data. There could be multiple things in the data which we need to clean, right? So we'll also understand what is data cleaning, and we also try to explore data as well, like what the data is telling us. Once we know what the data is telling us, then we have a clear cut idea what should be our next goal. Okay. 1 second. Yeah, my bad, my message was continuously visible. Okay. I hope it's okay right now, Shivani, right?
Yeah, it is.
Okay, so yeah, raw collection, raw data collection, then data is processed, then we clean the data. So cleaning data and data processing is somehow somewhat related to EDA process itself. So we need to do an analysis of the data to understand what the data is telling us. Only when we know that, then we can implement the models. Okay, and then once the EDA part is done, then we develop the models and algorithms, and then we try to take some decisions. And this is basically the data science process which happens. Okay, we'll try to understand what is EDA. EDA is an approach to analyze the data sets to summarize their main characteristics in form of visual methods. EDA is nothing but a data exploration technique to understand various aspects of data. Okay, the main aim of EDA is to obtain confidence in a data to a certain extent where we are ready to engage a machine learning model. That's what I told you, right? EDA is the first and the basic step in the data science workflow. Once you have done the EDA, once you know what the data is telling you, then you can take those insights or take the output of the EDA step, and then you can build your models. Okay, EDA is important to analyze the data as it is the first step I already told you. It gives a basic idea to understand the data and make sense of the data. I think this is very theoretical. We'll move ahead with some examples so that it will be engaging and you understand more about that. Okay, let me go through a few slides and then I'll explain using an example. Then comes your data visualization. Once you already have done your EDA part, like understanding the data, what the data is telling you, then what we need to do is we need to visualize it. So sometimes just looking at the statistical output of the data, it's not very hard for us to understand what the data is telling us. So we take help of various charts so that we can understand, okay, this is how the data is distributed. Okay, so data visualization plays a very vital role. Easily analyze the data and summarizes it. Easily understand the features of the data. It helps to get meaningful insights from the data. It helps to find the trend or pattern of the data. Okay, once we start visualizing the data, it start giving us more insights. So now we will be talking about the various charts which are available for visualization. And while we talk about the various charts, I'll also talk about some basic differences between this and that, which one to use in which scenarios. So let's get started. So these are the important charts for visualization. First chart is histogram. 1 second. Okay, first chart is histogram. Before histogram, let's try to understand what is a bar chart. You can see this is the histogram and this is a bar chart. Now, bar chart is basically, the definition says bar graph represent the total observation in the data for a particular category. Bar charts are basically used to compare the frequency, total count, sum, average in different categories by using horizontal and vertical bars. You can make it horizontal, you can make it vertical as well. Now, coming on to histograms. Histograms basically represent the frequency distribution of the data. But how histogram and bar charts are different from each other? As I told you, bar chart is nothing but it is used to compare the frequency, total count, mean, or sum or average in different categories. Now, coming on to histogram is a type of bar chart that is used to represent statistical information by ways of bars to display the frequency distribution of the continuous data. When we start implementing the code part, you'll have a better understanding how histogram looks like, how bar chart looks like, and all those things. Okay, these are the basics. The next one is box plot. If I go back to the previous graph, I also forgot one thing, that For example, histograms can be used in, let's say you want to find, let's say you have the students marks, let's say student English marks. So if you want to plot like the count of students who got English marks in exam in various ranges, probably you could use a histogram. Okay. Now what is box plot? As you can see, this is how a box plot looks like. Now box plot basically displays the five number summary. Okay, minimum, first quartile, median, third quartile, and maximum. Now if you look at this, probably I will draw a paintbrush so that you understand more about box plots. Now this is how a box plot looks like. Okay, now this is how a box plot looks like. Box plots are also called as box and whisker plot. Okay, so this is the minimum. Just 1 second, let me change the mouse. This is the minimum. This is the maximum. Now this is basically called as the IQR, interquartile range. This is nothing but it is a range between 25% percentile and the 75% percentile. Okay, so the 25% is basically called as Q1. This is called as Q3. It is also called as lower quartile. It is also called as upper quartile. Q1 is called as lower quartile and Q3 is called as upper quartile. And there is one more line to identify the median. This is nothing but the median. So box and whisker plot shows you five number summary of a set of data. One is your minimum, one is your maximum, one is your lower quartile, one is your upper quartile, and one is your median. Okay. Then the next type of chart is pie chart. Pie chart is one of the basic charts which I think everybody knows about. Pie chart represents the percentage of the data by each category. Okay. For example, percentage of runs scored by three batsmen like Rohit Sharma, Virat Kohli, and Rishabh Pant, probably. So what is the total percent of the scores which has been scored by these three batsmen? If I talk about only three, the total percentage is always 100%, right? So if we draw a pie chart, there will be three sections. One will be for Virat Kohli, one will be for second player, and third one will be for the third player, right? So pie charts basically represents the percentage of the data by each category. The next one is violin plot. Violin plots are, I would say, it is also very much used. uh, they are mostly used to plot numerical data. Now, if you can look closely, in between the violin charts, you can also see some box charts, box plots as well. This is basically a box plot. Okay, so let me go back to the next slide so that we understand more about what is the difference between violin plot and a box plot. Because by looks, they are almost similar, but they have their own differences. Now, violin versus box plot. So there are a lot of differences between violin plot and box plot, but I have just mentioned the two of the best differences. Okay. So box and whisker plots basically, if I go back to the paintbrush, they show median, mean, max, and ranges, etc. So they allow comparing groups of different sizes. They are super simple to create and read. So naturally, they are all over the place. They are mostly used, like box plots is very much used when we go ahead with the ADA part. Okay, but box plots can also be misleading. There could be scenarios where your box plots are not showing you the accurate information. Okay, so they could be sometimes misleading. They are not affected by data's distribution. When the data morph but manage to maintain their stat summaries, their box plot remains the same. That is the drawback with box plots. So this is where your violin plot comes into the picture. You can see this simple example. For all kinds of data, the box plot remains the same, but you can see how the violin plot is varying, right? So sometimes box plot could be misleading. Violin graph is visually intuitive and attractive as well. Okay. if I just draw a violin plot, let me draw a violin plot here. Hopefully I'll be able to draw it. Let's say something like this. Something like this. Okay. This is a violin plot. Internally, what it has is it has a box plot. It's very ugly. Something like this. Okay. Now, what do we understand is obviously these are your statistical summaries, which it is telling you this is your median value, this is your 95% confidence value, this is your Q3 value, this is your Q1 value, so this is your IQR range. Okay. But what is this? What is this area? This area is nothing but density plot width, also called as frequency. Okay. So when we start understanding the data, when we start plotting violin plot and box plot, you could probably spot the differences between them. Okay. Going back to the line charts are used to track change over line and short period of time. Line charts are used in time series data. You can see the x-axis is basically the time data, yearly data, and the y-axis is nothing but the population data. Okay, something versus time. So time series data, we have to do line charts. Let's say time series forecasting or any kind of time series analysis you are doing. So line charts are preferable to use. Next, we have strip plot. Uh, Strip plot I have not used much. Would you like to show some light, Shivani, what how to use strip plot and which scenarios to use?
So generally, you would want to use strip plots when, if you're plotting like several types of categories, maybe you have the people who. So in this graph, as you can see, it is absences versus G3. So this was during one of my sessions where I was saying like how many people are absent based on the grade that they received. So as you
Yeah.
can see, there's more concentration on the number 11 and also on number 8. But even in the number 11, most of them are around, like, there's a percentage where they only 20% are mainly absent. And there are a few more on the range of, like, 60, or there's one around the range of maybe 55 or something like that. So if you want to have scattered data between the categorical strip plots or the bar graphs that we plot, in that case you can have strip plots. So to understand strip plots in a very easier way, I would say, like, it's bar graphs, and bar graphs you have the scattered plot, and when you merge them together, what you get is strip plots.
Okay, so it's basically like used for categorical variables, right? Yeah.
Right.
Okay. So the next type, maybe you can also show some strip plot examples if you have in the use case as well. Okay, moving ahead to the heat maps part. So heat map is a data analysis software that uses color the way a bar graph uses height and width. So when we try to analyze numerical data, how to find the correlation, all these kind of things, you can definitely use a heat map. Okay. So this basically tells you the scores. You can see, I cannot zoom it, but if you can see 0.0 point 0, that means this variable and probably this variable are not related to each other, like 0.0 point 0. So it is basically showing you the correlation values. We'll talk about what is correlation in a couple of minutes, but this is how you can use your heat maps. Okay. These are the various steps involved in EDA. So the first part is data sourcing. As we already know, first step is collection of data. We should know what the source of the data is. Sometimes when we are working on some use cases, we do have to do some data mining techniques or do have to some scrape data from some online web portals or something like that. So that is basically your data source. It could be some areas where your data source is a Oracle database or some Azure data lakes. So it could be anything. You have to identify what your data source is. You have to extract the data. Then comes your data cleaning part. Data cleaning has its own steps, like handling missing data and to see whether some variables are important or not. Those kind of things can be done under your data cleaning part. Once you have done the cleaning part, unstructured to structured data, then comes your analysis. So analysis means univariate analysis, bivariate. We haven't mentioned the multivariate thing, but once I give you a small example, I'll also explain how to do the multivariate analysis as well. So after that, we also have derived metrics. Sometimes what happens is derived metrics, by the name itself, it is like it has been derived from some other variables. Now, for example, you're trying to analyze the age data. Let's say customer's age is a numerical variable, right? Somebody is having 20, somebody's age is 21, somebody's age is 60, 50. So it's just a number, right? So if you try to analyze the number, it could be a scenario where you are not able to analyze, you are not able to identify which are the specific age groups where you are able to see some spikes. So sometimes these kind of scenarios, what happens is we try to convert the numerical data to categorical data. One example is this, like converting a age to a age group. Now, if I create 5 bins, 0 to 10, 11 to 20, 21 to 30, 31 to 40, 41 plus, something like that. These kind of steps are basically your derived metrics. Okay, let's get started. Let's get ahead. Data sourcing, as I already told you, it's a process of gathering data from multiple sources as external or internal data collection. It could be two, public data, and it could be private data, right? So the data which is, I mean, I don't have to explain all these things. We already know about these basics, right? Public data, which is easy to access without taking any permission from the agencies, is called public data, publicly available. Private data, which is not available on the public platform, and to access the data, we have to take permissions of organization, right? Like banking, telecom. So domain specific data is basically your private data. After collection of the data, the next step is data cleaning. So all these basic things I have already covered. These are the some of the steps involved in data cleaning. How to handle missing values. We have everything covered in the next slides. Standardization of the data, outlier treatment. I'll talk about that. It's a very interesting topic. And then we have handling invalid values issue. After this, let's go back to the next slide. So these are some of the questions we need to ask ourselves about the data before cleaning it. So before cleaning it, we should be answering the questions. The questions are quite obvious. Whether the data which has been collected so far, does it make sense? Does the data you are looking at match the column labels? After computing the summarization statistics for numerical data, does it make sense? These kind of questions comes into your mind and you have to ask yourself. Okay, so handling missing data. How do we handle missing data? Some people say there is a thumb rule that, let's say you are dealing with some data sets, and let's say your column, one of the columns is having more than 30 or 40 percentage of missing values. So let me take an example to explain. Okay, let's just talk about this and then I'll explain the example. So these are the ways how you can handle the missing data. Delete rows or columns, replacing the data with mean, median, or mode. There could be some algorithmic imputation as well, or else we can use some prediction technique to identify the values and then fit the values. Okay, so let's talk about the first thing, deleting rows or columns. Some people say the normal thumb rule is that, for example, if I have a column, let me take a small example. Let's say I have customer name, I have customer ID, I have gender, I have geography, I have let's say is car. That means does the person has a car or not? And then I have car type. Okay, and I have multiple other variables. I'm not talking about that. So let's say so what people do is, I have also talked to a lot of data scientists. They also say that randomly, if your data, if you one of your columns is having more than 35% missing values, that means if you have total 1,000 records and if you have 350 missing values for gender, then you can simply ignore this column. this column is not used, it's not important. Some people say that. Some people also say if the ratio is 40, more than 40% missing values, you can ignore it. But there could be scenarios where you cannot apply this step blindly. Okay, so there are some techniques. So one of the examples is, let's say I have a column called as iscar and I have a column called as car type. Iscar is basically if you have car or not. Let's say yes, no. And let's say, summarizing it, 600 people don't have car, no car. 400 people have car. Okay. So definitely those who don't have car, for them car type will be null. Right? Agreed? Those who have car, let's say this guy has car. What will be the car type? Let's say XUV. Let's write it at XUV, SUV, something like that. Maruti, I don't know, but I'm just writing it. So it's quite obvious that people who don't have car will have null values, right? Now, just imagine you don't have the domain knowledge. You don't know this use case. Now, if you are blindly using this use case, if you start analyzing this column, you can see 60% missing values. Will you be deleting this column from the EDA or from your data analysis point of view? Yes, some people will do that. Some people will delete this column. But in real scenario, you shouldn't delete it because it is dependent on this particular column, right? So we already know, obviously, people who don't have cars, there will be null values. So we shouldn't delete it. In that case, we should either fill it with some mode values or we should fill it with some random values. So there are some different techniques for that as well. Okay, we'll talk about that. Next topic is replacing with mean, median, and mode. Now, what is mean, median, and mode? Let me explain you using a small example. Everybody might be knowing about mean for sure. Let's say I'm talking about four values: 4, 1, and 7. The mean will be 4 plus 1 plus 7 divided by 3. Mean is nothing but average. Okay. So mean is the statistical term for average. Okay. 4 plus 1, 5 plus 7, 12 by 3, 4. So the mean is 4. What will be the median of this value? If I just sort it out, this is how it look like. So the median will be the center value. So the median value is 4. Let's say we'll talk about mode. So this is not an example to talk about mode. Let me take one more example. Let's say 4 2 4 3 2 2 1 2, something like that. You have a series of numbers, and let's say you have two missing values. Let's say here is one missing value and here is one missing value. Okay, now how to impute the missing values? What value should you populate? If you are using the mode technique, your output will be 2, because mode basically is nothing but which number has the maximum occurrence. So here 4 has two occurrences, 3 has one occurrence, 2 has 1 2 3 4 4 occurrences, 1 has one occurrence. So 2 has the highest occurrence, so your output will be 2. So if you are filling it with 2, same example, 4 2 4 3 2 2 1 2. So I have two missing values and I'm using the mean technique. So what will be the output? 4 plus 2 plus 4 plus 3, 6, 10, 13, 15, 17, 18, 20. 20 divided by 8. So whatever the value will be, it will be 2.5. So you can write it as 2.5, 2.5. Okay. And then go ahead and try to build the model and see how your model is behaving. So machine learning is all about machine learning and EDA. All these techniques are hit and trial. There is no thumb rule to do it. But yeah, going forward, once you do it more and more, you know which scenario to use in what case. Okay. Algorithmic imputation is nothing but there are some machine learning algorithms which supports handling missing values as well. Okay. KNN, knife based, random forest, these are some algorithms. As of now, let's not talk about that. The fourth technique is predicting the missing values. So again, prediction of missing values is nothing but, let's say I'm taking these values and I'm going to do a time series forecasting, and based on my forecasting, let's say my output is 3.1. So I can write it down as 3.1. Then our next step will be considering all these data points like 4, 2, 4, 3, 2, 2, 3.1, 1, 2. We have to predict the next. Again, we will do a forecasting. This is a very tedious task, but it has been seen that it also works sometimes. Okay. So again, no thumb rule. It's all up to your intuition what technique you are going to use. This is the same example which I already explained, how to compute your mean, median, and how to compute your mode. Okay. So our next topic is standardization or feature scaling. Let me take a look at the watch. Okay, I still have 20 minutes time. So the next topic is feature scaling. Feature scaling, obviously I had to teach it in the data science part, but anyways, it is also I mean, it has to be, you have to know about all these concepts when you are dealing with the EDA processes as well. Now, feature scaling is the method to rescale the values present in the features. Why? Why do we rescale? One small example will help you out. Why do we rescale it? Now, as we already know, ultimate goal is to prepare a model. Okay, and model is prepared by in the computer, right? So computers understand numerical data. If I just provide them categorical data, they will not understand, right? So normally what happens is, I'll just give a small example. Again, customer ID, customer name, gender, geography, let's say height, and let's say weight, and some other features. Okay, this is the data which I have. Now, the height is something like this: 173, 171, 169, 165, 180. Okay, now as a human being, we already know what are the different scales where we can see the height variable, right? It could be in centimeters, it could be in meters, it could be in feet, it could be in inches, but we already know that this is in centimeters. I don't have to write this as centimeter, right? This is a human behavior, this is the human neural networks, how it has been created, right? So we already know this is centimeters. Now, if I pass this data to the model, let's say I'm building a model on top of this data. So computer for computer, this is nothing but a number. So what happens is, and let's say there is some other let's say age, let's say 12, 13, 20, something like this. So when what happens is, when we pass the data to the model, sometimes it is misinterpreted by the models that it gives you more priority to the maximum number values. It is a possibility that it might prioritize this feature on top of this feature, because my computer doesn't know that this is height, this is in centimeters, and this is age, this is in years, right? My computer doesn't know. So it is always asked to do a feature scaling. Now, feature scaling is nothing but it scales down to a certain scale. Now, one of the easiest feature scaling technique is, let's say I'm just taking the same example: 173, 175, 180. I'm taking three values. Okay, this is height. Now, if I have to do a feature scaling, let's say I'm trying to scale it down within for a scale of 0 to 1. So what I need to do is I can divide it by the largest number. So 173 divided by 180. What is the value? Let's calculate. 173 divided by 180. 0.96. 0.96. So what is this? 175 divided by 180. 0.97. 0.97. 180 is 1. Let's say 155, 160. So 155 will be 0.86, 0.86 and 0.88. 0.86 and 0.88. Now, when we do feature scaling, we what we do is we convert it into a scale of 0 to 1. It could be from 0 to 1, it could be from -1 to 1. It depends. There are multiple feature scaling techniques, but try to understand what is feature scaling. Okay, now the numbers are 0.96, 0.97. So these are in a scale of 0 to 1. Similarly, we can also do this with age. So now both the variables are termed equally, like interpreted equally by the machine. Tomorrow, if I have the height variable in meters, let's say 1.73, 1.75, 1.8, 1.55, 1.6. Again, these are not in a same scale, right? So again, we'll do the same technique. Even if we do the same technique, 1.73 divided by 1.8, the output is going to be same, 0.96, 0.97. You can see this. However, the core values are different. This is in 1.73, this is 173, but the converted values are almost same. Not almost, it is same, right? So let's try to understand what are the various feature scaling technique. So whenever we deal with numerical variables, we always do feature scaling. Okay. Importance of feature scaling: when we are dealing with independent variables or features that differ from each other in terms of range of values or units of the features, then we have to normalize or standardize the data. How to scale features? There are multiple techniques to scale features. Okay, one of the techniques is standardization, one of the techniques is mean normalization, one is mean max scaling. Okay, let's try to understand each one of them. I do have slides for that, but I don't want. I want to draw it and explain so that we have a better understanding. So the various feature scaling techniques. Okay, first is standardization. Standardization. Okay, standardization is nothing but replacing the values by their z-score. Again, what is z-score? It will be a long session if I start talking about what is z-scores and all those things. But try to understand the formula of standardization is like, what is the standardized value? X dash is your standardized value. X dash is nothing but x minus x mean divided by standard deviation. This is your mean, also called as this one, and this is nothing but your standard deviation. And we already know that the formula of standard deviation is, you don't have to memorize it. It's okay if you don't memorize. I hope I'm wrong. I'm correct. Okay, this is how it is. Let's say this example. I have income, I have age, and all those things. So what should be the new value of income? 15,000, 12,000, and 30,000. 30,000. So let's say I have 15,000, 12,000, and 30,000. So what will be the mean value? Mu will be 15 plus 12 plus 30, which is nothing but 27, 57,000, 57, 42, 57,000 divided by 3. So 19,000. Okay, so 19,000 is my mean value. So for this, if I replace it with the formula, okay, I need standard deviation as well. So let's calculate what is the standard deviation. Xi minus mu square. So you can just calculate this. Let me calculate it. This is nothing but, for the first one it will be 15,000 minus 19,000 square plus 12,000 minus 19,000 square plus 30,000 minus 19,000 square divided by 3 whole root. Okay, if you start calculating it, the output will be 7,400 something. Let's say 7,400. It is, I think it's 7. Okay, so I have already written it, 7,874. You can do it. Okay, so this is your sigma value, this is your standard deviation. So what will be the new value? 15,000 minus, what is the mean value? 19,000 divided by 7,874. If I calculate it, 15,000 minus 19,000 divided by 7874 minus 0.5. And this is how you can calculate for other values as well. So this technique is called as standardization. Our next technique is mean normalization. Mean normalization. Okay. So mean normalization is nothing but x dash is x minus x minus mean divided by max of x minus mean of x. Very easy to find. We already know what is the max, 30,000. What is the min, 12,000. Just have to replace the values in this formula and you will easily get it. Okay. This distribution will always have a range between -1 to 1. And the third technique is min max scaling. Min max scalar. Okay. The new value x dash is nothing but x minus min of x divided by same as this one, max of x minus min of x. The only difference is this part. This is mean of x and this is minimum of x. Okay. And this scaling always brings down the values to a scale of 0 to 1. So you can use any of these techniques to do the feature scaling step. Again, if you ask me which one is better, there is no straightforward answer for that. We always have to do a hit and trial, then build the model and then see how the model behaves. Okay. Our next topic is outlier treatment. Now outliers are the most extreme values in the data. Okay. Quite obvious, right? So it is an abnormal observation that deviates from the norm. Now if I draw a small example, let's say I have a graph and I have all the values somewhere here. And let's say let me draw a time series forecasting kind of graph. Let's say this is how the graph is moving, something like this, something like this, something like this. Okay. Let's say this is 2000, this is 2001, and this is 2020, something like that. In this data, I also have some data points here, 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 here. So outliers are nothing but which deviates from the data distribution. You can see if you find the minimum, so the mean value and the standard deviated value here, it will fall somewhere around here. You can see how the difference is. This is very far away from the normal graph. So this is basically an outlier. This is an outlier. This is an outlier. Now, how to handle outliers? There are various techniques to handle outliers. There are some anomaly detection techniques where you can use. Now, detection of outliers using following methods. We can identify outliers using box plots, using histograms, scatter plots, and z-scores as well. Okay, once we start with the practical part, you will have a better understanding because in the use case, we already have the outlier treatment in that. Handling outliers using following methods. Remove the outliers. So some people do remove the outliers, but removing the outliers sometimes backfires because when you are removing outliers, you are also removing some information out of it. That information could be very vital information. Okay, when you are dealing with very some use cases like in the healthcare domain, let's say you are dealing with cancer use case, cancerous and non-cancerous patients you have to identify. So obviously there will be very few people identified with cancer disease, right? So there could be scenarios in your data where some outliers could also carry very important information. So it's not the right way to remove them immediately. We have to analyze them, we have to see, and then we have to take the steps. Okay. There are some techniques like replacing the outliers with suitable values by using following methods: quantile method and interquartile range. We'll talk about that. And there are some machine learning models which are actually designed in that ways that they are not sensitive to outliers. We can also use these kind of machine learning models. Okay. KNN, decision trees, SVMs, ensemble methods. The next topic is handling invalid data. Now, invalid, so missing values was one part and invalid data is one part, right? So there could be scenarios where you are getting invalid data issues. What could be the possible reasons? It could be because of encoding and unicoding, right? So encode unicode properly. In case the data is being read as junk characters, try to change encoding technique. Try to use something instead of UTF-8. There are multiple encoding techniques, right? Sometimes what happens is when we are reading the data, we are not able to read it properly. If you change the encoding technique, you will be able to read it. Converting the incorrect data types. Correct the incorrect data types to the correct data types for ease of analysis. Example, if numerical variables values are stored as strings, it would not be possible to calculate metrics such as mean, median, etc. Right? So let's say you are dealing with age, and age is a object data, it's not an integer data. So it could be scenarios where you're not able to find the mean, median, and all those things, right? So always convert such data to integer data. If you're dealing with float data, convert it into float data. If you are dealing with date time data, convert it into date time data and then use it. Sometimes date data is also in strings. Let's say this example, 2013 August. It could be in string. We have to convert it into dates and then we can use it. This is also one of the basic steps which we follow. Correct values that go beyond range. If some of the values are beyond logical range, example, temperatures less than minus 273 degrees Celsius, there could be multiple scenarios, as in there could be multiple glitches, how your data is being captured. Could be scenarios where your data captured is somehow corrupted or something like that. So you should always correct that values. As a data analyst, that's your role. Okay. Correcting the wrong structure. Values that don't allow a defined structure can be removed. Example, in a data set containing pin codes of Indian cities, a pin code of 12 digits would be an invalid value and needs to be removed. So all these techniques comes under your EDA. Okay. Now I'll not move ahead with the next slides. Rather than that, I will try to explain you using some examples. I'll try to finish it in 10 minutes, Shivani, so that you can take it ahead. Okay. Now next topics are, okay, I'll just try to cover these things, univariate and bivariate analysis, and also I'll talk about derived metrics. Okay. Let me start a new paintbrush. Okay. Now let's try to understand what is univariate analysis and what is bivariate analysis. I'll again use the classic example which is very close to my heart, which is nothing but churn retention or churn prediction use case. Prediction. Churn prediction. Okay. Churn prediction is one of the use case where we are going to identify whether a new customer is going to leave the company or not. One classic example is, for example, I'm working for Vodafone. Just giving an example. I'm working for Vodafone, and over the past period of time, there are multiple customers who are leaving the system. It could be of multiple reasons. They are not happy, or the cost is high, or Geo is giving them good offers. Could be of multiple reasons. So my manager has asked, try to create a model based on the current data. It should be able to predict whether a new customer is likely to churn in next 6 months or 12 months. Okay, so let's say Vodafone has its own data set, like database. Let's say I have a database of 10,000 customers, and out of these 10,000 customers, 1,000 customers have left the system, so they have churned. That means why 9,000 customers have not churned. So what I will do is I'll create a model, let's say a classification model, and that model, let's say a new customer comes in, new customer, it should be able to predict that this customer is likely to churn. Okay, once we know this, there are some different strategies which we can follow and we can try to retain them. The main use case is that once we identify the potential customers who might leave the system, we can probably retain them. How do we retain them? By giving some offers, by giving some attractive offers and all those things, right? So that's the use case. Some people also tell me, why you always use churn prediction. Churn prediction is not very specific to telecom. It is not the reason why I use. Churn prediction is a very relatable use case. It is used in every industry. Banking industries, it is used in telecom, gaming industries, it is used in all the industries. Okay, because customers leave. Let's say currently you are using Standard Chartered. Tomorrow you will switch to ICICI. Next, maybe 3 months back, 3 months later, you will move to RBL, because RBL is providing me 8% RD, interests on RD. Right, that is also one of the use cases in churn prediction. Okay, let's get back to the use case. We'll try to understand what is univariate and bivariate analysis. Okay, so I have customer related data. Let's say customer ID, customer name. Anybody has any doubts? I haven't seen the chat section since a long time. Anybody? Shivani, you are taking care of that, or do?
Yeah,
Okay,
I'm into it.
okay, okay. Thanks a lot. Okay,
Mhm.
I have customer ID. I have customer name, gender, geography, contract type, whether he's a monthly contract or a yearly contract, and blah blah blah. And I have the column called as churn. That means yes or no. Okay. Yes, no, something like that. Multiple customers will have multiple values, right? Now, univariate analysis by the name itself, uni means one. So we have to analyze one variable. Now, analyzing one variable means, let's say, you're analyzing gender. So, what is the distribution of gender? Okay, let's say I have 10,000 records, 6,000 male and 4,000 female. As simple as that. This is your univariate analysis. Just analyzing one variable. Analyzing two variables, gender with contract type. Let's say there are three contract types. So let's just be like, I'll just ease up the example. Let's say we have two contract types, monthly and yearly contracts. Monthly and yearly. So yearly basically means you have a contract of 12 months. Monthly means you don't have any contract. You are free to go. Okay. Second step is bivariate analysis. Bivariate, what is bivariate? Gender is obviously 6K. I know that. But what is the further distribution of 6K? How many monthly and how many yearly customers? Let's say 3,500 monthly customers, 2,500 yearly customers. Similarly, in female, let's say 1,000 monthly customers and 3,000 yearly customers. This is your bivariate analysis, because you are analyzing two variables at a time. So, what should be your insights from it? There are more male monthly customers than female monthly customers, right? Male monthly, what is the ratio? 3,500 by 6,000, almost 60%. 60% of the males are monthly customers. Similarly, just 20% of the females are monthly customers. Okay, so these are the insights which you get. And when it comes to your use case, let's say your use case is churn prediction, right? So we want to analyze the churners who have already left the system. Only when we analyze them, we will know what are the characteristics of those customers, right? So what we do is we just refine the values. Let's say I have 10,000 records and I have 1,000 churners. So what we do is I divide my churners data in, I create a new data frame for churners data and a new data frame for non-churners data. And from this, I just try to analyze out of this 1,000, what is the gender distribution? Let's say 600 and 400. Male, female. So now we analyze in the overall data, the male is to female ratio was 60 is to 40. That means 3 is to 2. What is the ratio from the churners data, it's still the same, 600 is to 400, which is 3 is to 2. So the ratio is almost similar. That means gender has not much of role to play, but still gender can be used. It's not like gender is useless. Okay, because gender along with some other variable could give you some more information. Let's say the next step will be my bivariate analysis. I'll try to analyze out of this 600, how many are monthly customers and how many are yearly customers. Let's say monthly customers are, sorry, how many were monthly customers? Okay, this was the original level. So let's say monthly churners are 450, yearly churners are 150. Here monthly churners are, let's say, 350, yearly churners are 150. So what is the ratio for the churners? 450 by 600 into 100. This is the percentage of the monthly churners. What is the percentage? 450 divided by 600 multiplied with 100. 75% of the people who are male and monthly customers have churned. How many were monthly customers? Just 3,500. Out of 3,500, almost 450 have churned. Okay, you could get that value. Now, how many female customers have churned? 350 by 400. So these kind of analysis you need to do. So this is your univariate and this is your bivariate analysis. When you take it to the next level, let's say gender versus contract type versus geography. Obviously your graph will be very complicated to understand, but this is your three variable analysis and it goes on. So basically it is termed as three, like univariate, bivariate and multivariate analysis. Okay, these things you need to do to get more insights about the data. Then comes your derived metrics. As I already told, derived metrics are creation of new variables. Okay, again a small example. Let's say I have age. Obviously if I have age, I could be have values from 1 to 60 or more than that. Let's say my maximum age is 60. Let's assume that. So 1, 2, 3, 4, 5, 6 till 60 you'll have to plot something like this. You will be very much confused where you're, like, where are the most number of people are forming, where are they forming in this age group or in this. So sometimes what happens in these kind of variables, we don't get more information. So what we do is, it's not always, but I'm just giving an example of a derived matrix. Okay, what we do is, I know that the data I'm dealing with, I already know that it's financial related domain or telecom related domain. So as a data scientist, I should know how to bin them. Let's say I'm binning them as 1 to 18, 19 to 32, 33 to 50, and 50 plus. I'm binning them as 4 categories. And I will see now what is the distribution. Let's say now I can see 18 to 20, sorry, 1 to 18, like this, just an example. Then I can probably say, okay, these are the highest categories and all those things. So these are all intuitions which you need to follow. Once we go ahead with a live use case, you will have more understanding. And yeah, data analysis, I think in 1 hour nothing more could have been taught to you, right? So what is feature binning? Yeah, I just explained about feature binning. Feature binning converts or transform continuous or numerical variables to categorical variables. It can also be used to identify missing values or outliers. So these are some feature encoding techniques. Feature encoding helps us to transform categorical data into numerical. There are multiple encoding techniques: label encoding, one-hot encoding, and target encoding, hash encoding. Let me explain you something in brief. Uh, let's talk about encoding. Okay, now I already told you that ultimately the data which we feed to the model, it should be a numerical data, right? So if it is a numerical data by origin, yes, we know we feature scale it and then pass it. But what if it's a categorical data? How to pass it? because the model will not accept, right? Let's say I have gender and I have male and female. So how do I pass this to your model? One easiest technique is label encoding, which is nothing but you mark it as 1 and 2, or else 0 and 1, or else 1 as 0. Okay, mark it and then pass it. One other technique is also called as one hot encoding. It is mostly used for categories where there are more than two values. Now, one classic example would be, let's say I have I have geography. I have city. Let's say the values are Mumbai, Kolkata, Hyderabad, Mumbai, Kolkata, Hyderabad, Mumbai. Okay, let's say and one more. Let's say Delhi. These are the 1, 2, 3, 4, 5, 6, 7 customers I have. 7 customers data I have. Now, how do I convert it to numerical variables? Let me write the Delhi here itself so that it comes in one. Okay, Delhi. Now, what happens is we have to create multiple columns. Let's say I create multiple columns. Let's say how many valid values we have? We have 1, 2, 3, and 4. Nothing more, right? So what we need to do is we need to create 4 variables. Let's say I create a variable like Mumbai, not variable, column. I create Kolkata, I create Hyderabad, I create Delhi. So wherever there is Mumbai, I will populate it as 1, rest as 0. Wherever there is Kolkata, I'll populate it as 1, rest as 0. Wherever there is Hyderabad, I'll populate it as 1, rest as 0. So now I can easily feed the model this numerical data. Okay. And there are some concepts like dummy trap. Let's not talk about all of them. So dummy trap is nothing but when we are having 4 columns like this, it is normally recommended to just use 3 of them and ignore one. Why? Because it is irrelevant. Because if this is 1, this is 0, this is 0, it is quite obvious this will be 0. If this is 0, this is 0, this is 1, it's quite obvious this will be 0, right? So there is a concept called as dummy trap. That is the reason we ignore one of the dummy variables. We call it as dummy variables. Mumbai, Kolkata, and Hyderabad and Delhi are the dummy variables. One hot encoding is one of the techniques. There is one more technique called as get dummies. You can also use get dummies to convert your categorical data to numerical variables. I think that's it. Next, we will be talking about the use case. I don't have to tell you what are the use cases being used in EDA. EDA is a mandatory thing. It's the basic first step whenever you start a data analysis or data science use case. Okay, be it cancer data analysis, be it customer retention, be it anything, cross selling, upselling, any use case, EDA is a mandate. Okay, we have to do EDA on each and every use case. So that's it from my side. In case you want to in case you have any doubts, you can just let me know. We'll probably wait for 2 minutes. I'll just go for a water break, quick 2 minutes water break, and then Shivani, you can take it over.
Yep, sounds good.
Yeah.
So we'll start at 9:15 if that's okay.
Yeah.
Okay, cool.
Okay, I'm back. Uh, Shivani, if you want, you can take it ahead. You can start sharing. I'll just add you in the loop.
Okay, sure. Just can you confirm once if my screen is visible?
Yeah, it's visible. Let me let me make. Okay, now it's yeah.
Okay, great. Um, okay, so I hope everyone is back. Um, or should we actually wait until 15 because we said 9:15? What do you say?
Yeah, okay, let's wait for 2 more minutes.
Okay.
Okay, can we start, Shivani?
Yeah, sounds good. Okay,
Okay,
so
okay, let's start.
okay, so in EDA, so like Satyajit has already clarified the concepts really well. And now I'm going to be walking you through the use case where we are going to analyze, like, the so if you're a credit card company, then you want to analyze your customers, you want to see their behavior, you want to predict how they are going to behave over the time or how they have been in the past. So a few things that we're going to analyze is, so what we are going to cover, the first thing is to deal with missing values. The second one is to actually see how to work around with categorical data and visualize that data. And then we're also going to check up with, so if you have given somebody a loan, then what percentage of your customers, or what kind of customers are actually going to pay the loan, and if they are paying back, then how often are they paying back, and what type of class is paying the loan back much sooner than the other types of classes. So there's a lot more things that we're going to explore as we walk through. So let's start with the session. What So currently we have like three data files. The first one is application data, the second one will be columns description, which will be having all of the description of the columns that we have so far, and the third one will be the previous application data. So these are going to be the applications that have been previously submitted. And so I'm using Google. I usually prefer using Google Colab, especially because that's very convenient to go with. Also, unlike the last session, I'm not going to be coding live because it's almost like a 500 lines code, and I've already prepared the entire thing, so I'm not going to do that again. But yeah, we can do that maybe next time. So I've already mounted my drive, as you can see, and I've also copied the location where all of these four files are. So if you want to check out, then the way you can do that, this code cell will mount your drive for you, and you can just pick out whichever account you want to choose. And from here, so as you can see, these are the three files that we're going to have. So we'll put up the code and all of the data up on maybe our GitHubs, and you can check out from there. but not right now, after the session, of course. So I've just copied it from here, copy path, and I've pasted it right here. This is going to change your directory to whatever path you've set. And from there, there's a few libraries that we're going to use. So first of all, we're going to go with pandas, numpy, matplotlib, seaborn, and also some more maybe. So first one, the reason why you need pandas is because we are mainly dealing with CSV files, and files are best processed using pandas. And the second one is numpy. NumPy is usually used for dealing with the numeric values, and matplotlib is the one that you want to use for plotting the graphs. The reason why we also want to use Seaborn is that is also used for plotting the graphs, but your graphs that you plot with Seaborn are much more cleaner, and they're more visually attractive whenever you look at them. So the first file that we have is the columns description, and I'm going to put that into the DESC variable. With the encoding Latin, because you can't really use the UTF-8 encoding everywhere. So as you can see over here, we have the table, what table it is on, like what file it is on. So the first few columns, as you can see, they are on application data. And then we have the rows, the different types of rows that we have. Then we have description for each of those rows, what they mean. So you can go ahead and check out those descriptions whenever you want. And then we have what is the speciality of that every sort of row from that table. So moving forward, we're going to read the next file, which is our application data. So these are the two files that we have, the application data and the previous applications. So first, we're going to start reading the application data. And in the application data, we need to analyze a few things. So what exactly are we analyzing over here? We need to understand what kind of columns do we have, and what is the, so if you can see over here, we have different types of contracts, like it's a cash loan or it's a revolving loan, or what person, or what gender has actually taken that loan, and how many of them are eventually going to be responding to you, and what is the amount of credit or the total income of that person, and there are more stuff like that. So the reason why we need these information is so that we can eventually analyze. So if it's a male or a female, then is he paying the loan back? And if he is, then how sooner is he going to pay that back? And also you can see another column here, like if he's working or not, and what work does he do, and if he has completed his education, or if he's having a family, what kind of home he's living in. So all of these data, we'll be seeing how to use that afterwards. Now, to understand, to get just more information about this data frame, we're going to also check. I'm going to use the verbose as true. So what verbose means is you just want more information. If you said verbose is equal to false, you wouldn't really get the data types and stuff. So I'm going to get more information from here. So as you can see, these are usually, the integer values. Then we have the float values and objects as well. So these all data types we're going to have to work with. The reason why this is important is because then you know what kind of data you're dealing with, and accordingly you can actually convert that into if it's a categorical data or not, and then you can plot the graphs further on. So the shape of the data is 307511, 122. So that's like the rows and the columns of the data, and then we're just going to check with the target variable. So we're going to analyze the target column, and from the target column you need to understand you want to see if whatever values of the target column, if it's 1 or 0, and if it is 1, so if you see here, it is 1 or 0, and how much of it is 1 and how much of it is 0. So you want your data to be balanced in both the classes, in ones and zeros. But if it is not, then you need to ensure that it is balanced. But here first we need to know if it is balanced or not. So as you can see here, most of it is zeros, which is over, you can easily see that it's over 80%, but we need the exact value of how much of it is over 80%. So when I say target variable, what I mean by that is how many of the loans were actually paid on time. So the loans that were paid on time will be having the variable 0, and the loans that were not paid on time will be having the variable 1. So if you see here, most of them were paid on time except for a few. So if we understand the unique values, we are just having 1 and zeros. And then when we understand like what percentage of the loans were paid in time and before time, so 91% of the loans were paid on time and 8% wasn't paid on time. Now the next part, we will be actually dealing with the missing data. So many columns over here are going to be having the missing data. Only a few of them would be like, like will not be actually having missing data. So in your entire data frame, we have a lot of amount of columns. And from that, like Satyajit mentioned, if there's about 35% or 30% of missing columns, then usually someone might drop it because it's not really useful. But if it is actually more than that, then you might want to drop it because it's not giving you more information. But on the other side, you could also have those columns giving you the most information. So you want to make sure that you are finding ways to use those values and also fill in or deal with those missing data. So for the features with less missing values, we can actually use regression, and or the other way to deal with that is to take the mean of those values, and depending on those features we can fill in with the mean. Or the other way was, if you're having more than 40% of missing values, then it might be it might be just easier to drop those, or by other ways you can actually predict them. So if you're building an ML model, then you might want to use those features as the labels that you want to predict, and based on that you can actually get those. But again, it's no thumb rule, so we will first do some analysis and then we'll discuss. So first of all, we're going to check if the columns have more than 30% or 35% of the missing values, and then we'll be combining those columns which have more than 30%, and then we'll see how to deal with them. So currently, I am using the variable empty columns for understanding how many missing or how many null columns do we have in the DFAB data frame, which is our application data. So this is essentially like from empty columns, all of the values that you have. If they are more than 30%, 0.3 signifies 30%, times the length of the entire column, then you just want to, you want the count of that. So you're going to create a data frame of empty columns, and then you are also going to reset the index. So what I mean by that is you usually have over here there's an index, and then you will be having the other row. So instead we're just going to rename them. The index would be called as the row, and the 0th column over here, it will be called as the num count. And then we just print it out. So as you can see, the number of count for more than 30% are for amount goods price, the name type suit, and own car age, occupation type, and so on. Now what we are going to do is we're actually going to redefine the data description for the column with application data. So for that, we're going to go back to application data, and in the table section, as you can see here, so in application data, we actually have the table. So from table, we're going to pick application data, and then we're going to use this description to then correlate with the rows that we have. So the way that we do that is we're going to use the LOC parameter from the PD data frames, and from that we're going to access the table parameter, which has to be the application data. And when we set that, so I've put this information into the description application data, and then I'm analyzing the empty columns data frame with so what I mean by when I'm analyzing it is that I'm actually just merging the description with the rows so that I know what rows has which description. For that, the left one is going to be the empty column DF. As you can see here, this is the left one, and for the right one we need the description. So I'm just going to put that over here, and it has to be an inner join, and we will be putting that on the row column. So the row column over here as well, you can see, and it'll be based on the row column. So on is just like what columns do you want to compare. So it's row over here, and also in the application data we had the row column. And then when I do that, so what we understand from this is we have actually gotten all of the rows with the descriptions. And the reason why we want to have those null values greater than 30% is because so if you can see, then most So since this is 64, it means that the total columns that have more than 30% of the null values are 64 out of the all the other columns that we have, which means like not much of our data is null values. And then since there's no rule of thumb that we're going to drop those 30% of the null values, we're actually going to be normalizing most of the information. So for instance, if most of the columns are normalized information and the description is unclear, then I'm just going to go ahead and remove the normalized information values. Or in the latest stage, I can also analyze the other 61 columns. So currently we're going to be working with amounts, good price, the own car age, as you can see here, and then the occupation type. So what kind of occupation does the client have, the age of the client's car, and the consumer loans that it is for the price of the car, price of the good, or rather, just right now car. So over here, we are going to consider these three columns, and the rest of the 61 columns from those 64 columns, we're going to be working on them afterwards. So I'm going to be analyzing what are the missing values. So first of all, we need to plot another graph which will tell us like what is the number of missing values and what is the percentage of missing values for every single category for all of those 64 columns. So as you can see here, we have all of these columns over here, and then we're also analyzing the percentage of the missing values. So for these few columns, we have about 70% of the missing values, and for the rest of them there's like almost 0%. But so what we understand from this is there is enough missing values, but just not for every column, and most of the columns do have the entire data. After that, we need to actually list out the missing values which are greater than 30%, and then we're just going to remove these three columns because we need to use them. And for the rest of the 61 columns, we're going to just drop these columns for now. And then we also need to analyze, like, from these DF app, the 61 columns, how many of them are going to be having more than 30% of the missing values. So once you do that, so as you can see, the amount, so we're now going to be analyzing the amount immunity, which is having a lot of less, missing values. And from amount annuity, sorry, we are going to, try to impute the missing values. And from here, since the column, it's also having outliers. So since it is having outliers and it is very large, we wouldn't really be, it wouldn't really be the best way to fill those with means, because outliers can, outliers, like Satyajit explained, are not exactly in the data, but they're outside most of the concentrated data. So you can't really fill that with mean, because that wouldn't be really the way you want to deal with it. That's why median over here will be much helpful. Now, the reason why you want to use median is because unlike mean, median is actually, it's going to consider those outliers as well, which mean wouldn't really be doing. So for that, we're first going to fill the missing values with median. So as you can see here, we're actually taking the median, and then we're going to fill this with the median. And then for the columns that have null values, we are going to be checking, like, again, the columns which have null values, because we just filled the rest of them with the median. And then we're going to, since all the columns now have with 0 values, we're going to remove the ones which are equal to, 30%. So now we don't really need those columns. So I've removed the unwanted columns from the dataset over here. Now these are the unwanted columns, and then I'm not really going to work with these. So I just remove it over here by just dropping them on axis 1. And now in the next step, we have this XNA value. Now, what this XNA value signifies is that it's not available, which means we need to find the number of rows and columns and then implement the suitable technique on them to fill those missing values. Or if we do not want to fill them, then you just drop them again. For that, you actually need to find, now since XNA is not 1 or 0, it's obviously not numeric, it is categorical. So we need to find, like, how many of those are for every gender column, like what is the XNA value, or how much of those are XNA. So if you use this piece of code for organization type, if it says, like, even for code gender, which is male or female, then the XNA value is like 4,31. And over here, the organization type and shape, the XNA value is much more than that. So for organization type, there's 4 from the gender column, and then there's 55,000 from the organization type column. So over here, we need to describe the gender column to check the number of females and the males now. Now, since the female is also having, okay, let's check here. Okay, so if you see here, then what we do is we're actually finding the value counts, like how many of these. So what value counts is going to do for you is it's actually going to find out what are the unique values. So for in case of unique values, if you just want to find out the unique, then you can actually do by UNI. So this will just give you the number of unique values, and it wouldn't really give you the counts. Whereas value counts will actually give you the number of unique values, which could be male, female, or XNA in our case. And in case of females, as you can see, there's about 2,02,448 people like who are male, who are female, and then we have about 1 lakh people that are male. And over here, we're going to also analyze on the organization type. So when you analyze on the organization type, what you get here is that for count, unique, top, and frequency. So for the organization type, we have, just a second. Yeah. So for the organization type, we have a total of 3 lakh rows, of which 55,000 are having the XNA values, which is not a good idea. So what we are going to do here is we're actually going to be working with this 80%, and then we are going to drop all of these 55,000, which will not, obviously, because it is 18%, so it wouldn't really have an impact on our data if we just drop it out. So from once we drop this, then we're going to analyze it again. So for code gender, the name, family status, and for the income type and occupation type. So once we've dropped it, you just drop it over here again for the organization type, and if the variable associated with organization, if it is in the category of XNA, then you just want to drop it. So you've dropped it over here, and you keep those indices, and then you just want to take you just want the shape of your data now. Once that is done, now we will be actually starting with the categorical analysis. And over here, we're going to be using the bar plot, which again, Satyajit has explained really well. So as you can see, we have, first of all, the code gender, which is if it is a male or a female. Then we have the name, family status, income type, and the occupation type. So let's understand this a little bit. So first, in this case, we have male and female. So in here, we have 65 to 62% of which are female, 61% you could say. And then for male, we have about 39%. And then we have the next column that we are plotting is the name, family status. In this case, which is married, not married, if it is a civil marriage, separated, widow, or we just don't know where do they fall. So for that, as you can see, for married, we have the most, and then it just keeps going down for singles and civil marriages, separated, widows, or the people that just we don't know. So it's 0 for the people that we don't know. And then we have the name, income type, which in our case is if he's a working person, if he is an associate, a state servant, and student and businesses, they don't really take those things. So we're not having any information about these. And then we go back to the next column, which was the name, income type. So for name, income type, we have these columns, which are the laborers. Then we have sales staff, core staff, managers, drivers, and then so on until HR staff and IT staff. So for these, again, as you can see, the highest percentages for the laborers. Then we have the sales staff, core staff, managers, drivers, and then it goes down for the least, which is secretaries. Now, once we have done this, what we did understand from here, as we wouldn't find much insights related to the defaulters, so here we just get an idea of which category of people are present in abundance. So most of our people from here in this data is like the laborers, then we have the working people involved mostly with the company, and then we have again the married people and unmarried, but unknown, there's nobody from unknown. It's just a column that we have. We do not really have any students, any businessmen, prisoners, and then we also do not have any reality agents, HR stuff, IT stuff. So most populated ones are these, the one you can see here. And also most of them are also females rather than males. So what we get here is just we're analyzing what are our customers, like who are we actually serving. So now we will be starting to plot the features. Now when I say we will be plotting the features, what I mean by that is we are going to be using the application data, and then from that we're going to be seeing the percentages for each of those target variables. So whatever people that we just targeted, we're just going to see more of who paid the loan or who didn't pay the loan back. So for that, you have you want to target the features, which is the temp index over here, and temp is just I've just created a temporary variable from where the feature is. I'm just creating a function right now which is called plot features, and then it is a type of feature that you want to target over here. The label rotation, which currently is false, but you can set it as anything that you want. So you can put it as true or you can put it as false. If you want a horizontal layout, then it's already true right now. So horizontal layout is like your bar plot or anything in the horizontal direction. Now in temp data, so in the temp variable, I'm just using the df data frame, which was the application data. So df underscore app was our application data frame, and then from that data frame we're accessing feature, and then we want the value count. So like again, as I said, the unique values, and then what number do we have corresponding to that unique value. And then for df1, it is the same feature. For that we will be using the absolute values, and then we will be setting the absolute values to the temp values, which means the values that we got from here. So once we do that, we need to also find the T1 percentage. So the T1 percentage is essentially the features across the target variable, and then we're going to group that with the features, and you're going to take the mean of it. So once you do take the mean of it, you're going to sort those values in the descending format by the target variable. So you want to also, like when you get the T1 percentage, you want to sort those values as per the target variable. Now if you remember, the target was the people who paid the loan back, and the people who didn't pay the loan back in ones and zeros. So you're going to sort them in the descending values, and then in the horizontal layout, if you have a horizontal layout, then this is the way you want to plot it. Like the number of columns is going to be 2, and this is just your figure size. And we're going to use subplots over here. So subplots are like multiple plots that you can plot together. And again, we have the number of rows is also 2. So the other way that you can also do it is like if you have a horizontal layout, then it is obviously going to be columns, but if it is a vertical layout, then it's the number of rows. And then we use, yeah, you were saying?
I think Shivani, you can easily plot them and show them. That piece of code explanation will be little bit tough for people to understand. For the time being, I could say that just take the code and you can run it. Like you can utilize this code in any of the use cases. To understand more what exactly is happening in background, probably you could see line by line and try to understand it. Okay, maybe if you can see the plot features, people will more understand how it is actually plotting it.
Okay, yeah, I think that's a good idea as
Yes,
well.
yes.
Okay, so yeah, like you can understand this much better if you try it for yourself, and feel free to also modify the code according to your needs. So we're just going to in the end, I'm just going to skip this part for now, and maybe I can come back to explaining it again. Just a brief. So we have the categorical values. We're just going to select the data type, which was object. So if you remember, we analyzed the data types up in the first column, like not in the first column, but the initial code blocks where we saw it was integers, floats, or objects. So we're going to understand like the categorical types, which are usually the string, but over here we have objects. So with this, we have these categorical columns, which have the categorical values, and then we're just going to go plotting them. So if you can see, there's married, single, civil, separated widows and unknowns again. We're just plotting the same thing, but over here, what we are doing is we're going to plot those features, the same features that we had plotted above. So as you can see here, the percentages of applications where the loans were not repaid. So like there's still, people haven't still paid those loan backs, and most of them were the single or not married people. And then we have the civil marriage people, and the least of them were the widows. So maybe, just they didn't take the loan that much as these guys did, or there could be some other reason. So we need to also understand that afterwards. And then we are going to pick the name income type. So the name income type was if it is a working person, or if it is working as a state servant, if it's a student or businessman or stuff like that. So we're also going to check that from here. So the people, the percentages of people that we actually have here, the absolute values, and then the ones who actually paid the loan back. So for the ones who were on maternity leave, the most of the time they didn't really pay the loan back, like even 40% of them didn't. The working people, only 10% of them didn't pay the loan back. But in case of state servants, only it was 6% or something around that line. So most clients are the married people. Civil marriages and the single people have higher chances of defaulting than the others. And then in case of students and stuff, the working class usually applies most of the loans, and a very low default, and have a very low default rate. Therefore they are the most reliable customers that the company is going to have. The other insights that we get from here is that the clients who are unemployed and also are on maternity leaves, they have the higher default rates, although they are the minority as compared to the other incomes. And also the commercial associates and the state servant persons, as you can see here, are fairly more reliable, because they're actually paying the loans much faster than the maternity leave guys. So then we're also going to target the occupation type, which is, as you can see here, just a second. Yeah, so as you can see here is the laborers, the staff, the HR staff, IT staff, or secretaries and stuff. So if you can see here, then the low skill people, like the laborers, the waiters, drivers, especially the ones which have the lower income ranges, they are most likely to be the loan defaulters. Whereas the higher paid staff are, have less chance of defaulting, so they are more reliable. And now we're also going to be plotting the education type, based on the kind of education that these guys have. So we have the people with lower secondary grade, who have done higher education, who has an incomplete higher education, and who have or who possess an academic degree. So for the academic degree, it's really less, so it's near to zero. And then we also have the secondary special people, or the higher education people, or incomplete higher education. And if you see here, this plot is really interesting, because the lower secondary people are the ones who are mostly in the debt for the loans, and then we have the least one for the academic degree people. So most student loans are for their secondary education or the higher education. This is the first understanding that we get from here. And then the lower secondary education schools are mainly for the most risks that the company has from here is from the lower secondary education loans, which are generally followed by these groups, the lower secondary or the secondary and the secondary special. Although these could be eventually paid, since they are going to be leading to a higher education or an academic degree, but these two are much more riskier for the company. And then we are also going to plot the features for the organization type. So for the organization type, we have, if it is a transportation business, if it is a security industry, university, police, military, religion, or any of those other types, if it is an insurance company or a bank or stuff like that. So if you see here, then the absolute values, which is the highest, it is for transportation type 3. So it's not really clear over here, I'm just going to scroll down. Yeah, for transportation type 3. And then we have industry type 13, and then industry type 8, and then restaurants, constructions, and so on. So this graph just goes down, because we said that, if you remember in the code, we set it as descending. So for ascending, we set that as false. That's why we have everything in the descending order. So as you can see here, what we get from this data is most of the loans are taken by the transportation type 3 people. And then in the second, people who are taking most of the loans is industry type 13. And then we have industry type 8. And then the least loan is taken over here, which is, industry type 5 and type 1, and then the security industries or universities and police and stuff. But if you see here, then there are a lot of people who haven't really paid their loan back. So the organizations which, like if you have the transportation type 3 people, or those organizations, and industry type 13, then these are the highest defaulters. As you can also see, we have a certain range. So until restaurants, until these people, there's a higher risk. Until, you could also, like, you can set a default range for where you want the defaulters to be and the ones who are not risky for the company. So I'm just going to keep it maybe until relators, and from relators, these are the ones which are the highest defaulters. And then the rest of them are actually, not that risky for the company, or you could say like the trade type 4 is not at all risky for the company, and these are the ones that the company can rely on the most. Once we have done that, we also have the name housing type. So in case of name housing types, we have what kind of housing is the specific person having, or the people that have taken the loan having. So there are municipal apartments, and they are also living with the parents, or it could be an office apartment or a co-op apartment, the one that you share. And there's also a rented apartment. So most of the people that have applied for the loan are from the rented apartments. Very less in comparison to the absolute values for the rented apartment. Very less are from the rest of the values. And for the co-op apartment, there's not really any. So the housing type really affects a lot, because then you also need to check. For the apartment, there's the highest amount of loans. And the people who haven't paid the loan back, in comparison to these, are the people who are living in the rented apartments. And then the next one are the ones with, like, the ones that are living with parents. And the least ones are the office apartments, which means the apartments that the offices have provided them with. So over here, 8% of these are, like, the default rate. And the people living in a rented apartment or with the parents are, but very rare. They're like very less, but they're also very risky. So these are not, the ones that the company can rely on. But the office apartment people, these are the ones that the company can very easily rely on for the loans. And then we also need to check the weekday process start. So, like, when does their week actually start? Does it start from Tuesday, Wednesday, Monday, Thursday, Friday, Saturday, or Sunday? So most of these, for most of our customers, the week starts from Tuesday, which is the highest. And then for very less of those, the week starts from Sunday. So also over here, as you can see, the weekdays are more common, but it's not really giving an insight for the defaulters, because most of them are, almost the same range. So we do not really understand which one is more reliable or which one is not. So most clients are like, not accompanied by anyone when they apply for a loan. So there's not any significant difference in the people who are going to give, who are actually going to repay or not. So this is a redundant feature. This is the first analysis. And the second one is when you're actually creating any ML model or something, this is the one that you can just exclude, because we're not really getting any information from here. And then we are going to be, checking with the region, and then we're also going to check with the work region. So for the people whose permanent addresses match with the contact or the work addresses, and if they are going to be risky for our company or not. So we're going to be checking the regional region. And from that, what we understand is the regular region, like, or the people that are where they do not live, or where they do not work. So the ones that who live in the same region, it's 0. And then, I mean, like, who do not live in the region, we're going to specify them with 0. And who do live in that region, we're going to be calling them as 1. So as you can see, the ones who do not live over there is very high. as comparison to the ones who do live there. But again, this is also not very useful for us, since this is also almost like a similar graph. And also for the work region, like if their work address is corresponding to the address that they live on, so for them also it's not like it's not giving us any more information. Like we cannot really understand if it is something that we can benefit from for telling your if you have to tell your manager if these are the people who are most risky, then we do not really have any information from here. And then we're also going to be checking with the regional city. So when I say that, we're going to be checking in the regional level, we saw that the same people are also risky over here. So if it is a city or if it is not a city, as a city level, it has significant difference in default rates, but we don't really have to consider the regional level as a determining factor because it's not really helping out much. It's just a 2% rate over here. And over here as well, we have a 4% rate. So this is something that we might be able to use, but it's also not very useful in this case. Now we're going to be checking all of the categorical features. So in case of the categorical features, we need to check the genders. So first of all, let's go with the contract types. So let's see for cash loans, and then we have the revolving loans. So if you can see the revolving loans, and as compared to the cash loans are the ones which are not paid very most of the loans which are cash loans, there's a higher rate that they will be paid very late or they are not being repaid. And in case of revolving loans, they are paid much faster than the cash loans. So this is some valuable information we have here. And the other one is if you see here, so okay, no, here. So over here, the females are the people who are taking most of the loans, and male are the people who are taking less amount of loans. But in case of the percentages of paying the loan back, males are the ones who are not going to pay the loan very often, but females on the other hand, as compared to males, then in the contrast, females are more likely to pay the loan much faster than males. And the next one that we have over here is the clients who own a car or not. So the ones who own a car are less likely to not repay the loan. So like the ones who do have a car, they're going to be more inclined to paying the loan back. So if you can see no and a yes. So flag own car, which means do you have your own car or not? And if you don't, then as you can see, for no, there's a higher chance that they're not going to pay it back so soon. And for the ones who do have a car, they might be able to pay the loan back much sooner. And also the next categorical data that we're going to understand. So the reason why this is categorical, although it is just two tables, n and y, you can convert them to 0 and 1 if you want to convert them to numeric. Eventually, while feeding the data to your ML models, you might want to switch them to zeros and ones. So right now it is categorical because it has yes or no, so y or n. Again, so the reality estate people are, the ones, so most of the people who own the real estate are more than the double of the ones who don't really own the real estate. But both the categories have around 8% chance of not paying the loan back. So again, this is not a very valuable insight. So from the numeric columns, I am converting all the variables into numeric over here, and there's a two numeric like the what do you call it, the two numeric method that you can apply just straight to the entire data frame, and it'll convert everything for you. So yeah, so once you do convert them into the numeric values, then I'm going to be having the certain derived metrics. So let's talk about the derived metrics right now. Now, creating the bins for continuous variables, like for example, we have amount, income, total, and the amount of credit that people have taken. And there's like it's not exactly one value for that, it's given in the range. So I want to convert those range into the bins, like the slots. So I'm just going to convert that, if it is in the if it is in this range, then I just want to convert this into here, and then I'm just going to slot it with the labels. So as you can see here, we have converted these values for amount, income range, and for amount, income, total. And then once we have done that, we're going to divide the data set into two targets: the people who have paid the loan, or the people who haven't paid the loan or who are having difficulties with paying the loan. So for target 1 is the one that people are having difficulties, and for target 2 is all of the others, so like also the ones who have paid the loan or who are not having difficulties with the loan and stuff like that. So for target 0, I'm just going to convert like all of the values from the so from this data frame, the app data that we had, we're going to target the feature called the target. And then if the value of that particular variable or the feature is 0, then we're just going to put that into a variable called um, target 0 df app, and then the same for target 1 df app. So as you can see, we have calculated the imbalanced percentage, and most of them is target 0, and there's very less which is target 1. So we understand like most of them have actually, most of them are not actually having paying with the payment difficulties. So then we're gonna go down and plot some more information like the count of target variable per category. So we have 1 and then we have 0. And then we're actually going to go ahead and plot a uniplot. Now, why do you need a uniplot? You need to understand like from the above, you need to understand like, maybe understand what, if it's a female, then what is the occupation type? And if it is a male, then what is the occupation type? So maybe, we might have females under the occupation, whatever is the occupation, like maybe cooking staff or HR or other professions who are paying the loans pretty fast, or their male counterparts like other private service staff or secretaries and stuff who are not being able to pay the loan much faster, or who are able to pay the loan much faster. So for that, we are actually going to be using a uniplot. And what I say by the uniplot is, I'm just going to start like, this is basically where you're going to just set how you want your plot to look like. So RC params is just the specific parameters. Like generally, if you're using, if you're familiar with Bash shells or Vim shells, then you have the Vim RC that you can configure. This is something similar to that. You just are able to configure your entire plot over here. And then this is the data set that we're using. We do not have like, the data is set to hue, and then we have the figure and the axis. Now, this is specifically important because we're again plotting subplots, and then we're setting like the y scale is going to be log, and then we have a count plot for all of these because we are counting like what is the female and the male ratio for each of those occupation types, like again for private service staff or cleaning staff or cooking staff or stuff like that. So let's plot the uniplot, the function that we just defined over here. And then we have the target 0 with the column occupation type. And then this is just, I'm going to be defining the distribution and for target 0. So this is mainly for target 0, which means the people who are not really having difficulties with paying the loan. So as you can see in laborers, for female it's blue, for males it's orange. So in females, less number of those are laborers and as compared to males. And in sales staff there are more females again as compared to males. And then in core staff there's more females, but over here in drivers there's less female as compared to male, and so on. As you can see also in the HR staff and the secretaries, this is having much more of a difference. Like most of the females are secretaries, and also they are not having any difficulty paying the loan back. So most of the males who are in the security staff, as you can see over here, then they do not really have a difficulty in paying the loan back. And also if you look over here for drivers, then most of the males who are drivers, even they do not have any difficulty paying the loan back. And the same for medicine staff. But in this case, the women who are in medicine staff, they pay the loan much faster than the males who are in medicine staff. So this is how you're going to be actually reading the data that we have currently. And then also for the people who are, so target 1 DFAB, which means the people who are having difficulties with the payment. So over here, if you see for the medicine staff, females are the most people who are also having difficulties with paying with the payments. But the key feature to understand over here is the Y label, which means you also need to understand like what number of those are having the difficulties, and these two plots are going to be these are going to be analyzed side by side. So as you can see here, in case of drivers, the males who are drivers, they're also having difficulties paying the loans as compared to females. And then in case of high skilled tech staff, then over here, females are having more difficulties paying rather than the males. And in case of HR staff, the males who are in HR staff, they're not having much difficulties. But on the other side, the females who are in the HR staff, then they're having more difficulties in payment of the loan, back paying the loan, so repaying the loan basically. And then we're going to be having a pivot table where we are going to just put the occupation types and the gender side by side, and then we're also going to be targeting the target column as the values like zeros and ones, and then we're going to plot a heat map. So as Satyajit explained, heat maps are really important when you are going to be analyzing based from, so over here we have the genders versus the occupation type, and they're going to be analyzed against the target variable. So in case of the other plots, the values might be replaced with another parameter called hue, and then you can just set it, but over here we have values. So over here, if you can see, then the females with the occupation accountants or the private services, as you see over here, then the private services people, they're more likely to be paying. So for green, it's the ones that are, the cooking staff or the HR staff, and also the females, they are the most defaulters. So okay, sorry about that. So they are the most defaulters, which means they're not being able to pay the loan much easier than their male counterparts. And then for the low skilled male workers, they're also having a higher rate of defaulters. And when I say defaulters, it's just the people who are not paying the loan on time, or who are exceeding the time limit, or maybe you're just not paying the loan back. And you can also see that from here. So from the yes or no values, you can see that so what we can actually conclude over here is that as per the heat map that we also saw above, and we're going to be plotting certain heat maps over here as well. So distribution of the car owner flag. Now over here, we're going to be actually checking the car owners, and as you can see, the people who are females haven't really paid it, and the people who are males and who also have a car are more likely to pay it back. And then it's the same for target 1, which is the people who are having difficulties or who are defaulters. And then we're again plotting a heat map over here. So what we conclude from here is that as per the heat map over here, as you can see, the male candidates without the car are the ones which are not going to be able to pay the loan as compared to the other subcategories that we see over here. And then as per the bar plot, as you can see over here, the people without the cars, so if they do not have a car, then these are the people who are going to be the most defaulters. And then if we just check it out furthermore, then the females without the cars are the most defaulters, like over here, as you can see, then as compared to the males without the cars. Now moving forward, overall, if you just have to understand it, then most of the people without the cars are the defaulters. So like if you have a car, then you're most likely to pay the loan back. This is the key insight that we get from here. And then we're also going to do the same for the contract type, like if it is a cash loan or the revolving loan. And when we analyze it, we're again going to be analyzing it across, the male or the female genders. And then we're also going to plot the graph over here, like the heat map, and then these two bar plots. So what we understand from here is that for the revolving contracts or the cash contracts, target 1 is the key graph for us. So we're not really getting much information from the cash loans, but from the revolving loans, females are the ones who are most likely to not pay the revolving loans. And as compared to males, males are going to be, the first ones to pay the revolving loans as compared to the females. So even from the heat map, we understand like the male candidates with the cash loans are the ones with the highest default rates. Like they're not going to be paying the loans much easier. And then also, if you analyze the same heat map along with the bar plot, then we understand that it's clear that both the males and females having the cash loan are almost equal to the same ratio. So but looking even at the revolving loans, although the numbers are less, but the females who have taken the revolving loan over here, then they're the most likely ones who will be having difficulties paying the loan back.
Shivani, can I give you some suggestion?
Yeah.
Can we ask the students to go through the code themselves? Because I pretty much think that they at least have the Python knowledge. In case they don't have, they can reach out to us to understand the code. We can hand over
Hmm.
the code to them, and what we can do is, I had shared you the EDA use case PPT, right? So we
Yeah.
can share the insights with them so that they will understand what kind of insights we're able to get. How about that?
Yep. Yeah, sounds good to me.
Yeah,
Because this is almost like, we're just
yeah.
analyzing with different types of features, and it's something that they can also understand on their
Yeah,
own.
actually, one odd thing was that I should have used a easier use case. This is pretty big use case, and it has a lot of rows and lot of columns. That is the reason it's bit complicated to explain, and people are also getting it complicated. So we'll send the code to all of you. We'll upload the code, and you just go through it. In case you have any questions, you reach out to us. Probably you, Shivani, you can talk about that PPT maybe. That will be interesting for people to get insights.
Okay.
Or else, do you want me to open?
Yeah, can you please do that?
Okay, I'll do that. Let me
Thank
present it.
you.
Yeah. Okay, just okay. Let me present it. Okay. Okay, I'm already sharing it. Nice. So, guys, this is the overall use case. My voice is audible and my screen is visible, right, Shivani?
Yep, it is.
Okay, so yeah, guys, this is very wide use case. So for us also explaining the use case is pretty difficult, at least in 1 hour. Uh, so the business understanding is clear, I think, from this point of view that the loan providing companies find it hard to give loans to the people due to their insufficient or non-existent credit history. Because of that, some consumers or customers use it as their advantage by becoming a defaulter. Suppose you work for a consumer finance company which specializes in lending various types of loans to urban customers. You have to use EDA to analyze the patterns present in the data. This will ensure that the applicants capable of repaying the loan was not rejected. So we are doing EDA to get more insights, and using those insights we need to take the next step of creating the model. Okay, in case you want a easier use case, I'll also send another video of mine. I think 2 months back I had given a session on telecom churn prediction. That use case would be for a beginner level, so you can go for that as well. Okay, so the first thing whenever we are analyzing these kind of classification problems, be it fraud versus non-fraud, or churned versus not churned, or this versus that, we need to analyze the target variable. So what is our target variable here? That whether a customer is defaulter or not, right? So the first intuition which we get is the target variables ratio was 92 is to 8. Okay, these plots are basically taken from the code itself. Okay, and this is just a summarized PPT. So data is highly imbalanced, ratio is 92 is to 8. So most of the loans were paid back on time, which is target 0. Target 1 are the defaulters. So our main task as a data analyst is to analyze these areas, only these records. Okay, we'll also analyze these records, the 0 records, but more information we need on this area, the people who are defaulters. Okay, so we need to analyze the data with other features while taking the target values separately to get some insights. So from the missing data, what we got a lot of information, right? A lot of variables are there which are having more than 50 percentage of missing values, and there are many variables which are in the range of 0 to 1 or 0 to 2. Okay, so as I told you, there is no such intuition that If it is more than 50% missing value, ignore that column. No, it is not that way. I mean, that is the most easiest way and the most naive approach. But as a data analyst, there is also an expectation that you should know what kind of domain you are working in, and based on your domain knowledge you will take that action. Okay, so many columns have a lot of missing data, 30 to 70%. Some have few missing data, 13 to 19%, right? Some have in this range, this one, okay, this one, these ones are having 13 to 19%, and many columns also have no missing data. This is our initial finding. So for features with less missing values, we can either use regression to predict the missing values or fill with the mean values. Okay, that we already learned. For features with high number of missing values, it is better to drop these columns as they give very less insight on analysis. As I have already mentioned, there is no thumb rule on what criteria do we delete the columns with high number of missing values. So we have done a small analysis and have taken decisions. Okay, so anyways, once you have the code with you, the recommendation would be you run the code and you watch this video in parallel so that you will understand more. Okay, this is the initial intuition from the data. Total columns having more than 30% of null values are 64. There is no thumb rule to drop the variables having more than 30% null values. As I already explained you the scenario, right? Car is car and car type. We cannot blindly remove those columns, right? So it's up to you how do you deal with it. So I have already dealt with this scenario. Detailed explanation is already present in the code. Okay, once you see it, then comes your categorical analysis. We have to do the univariate analysis. Univariate analysis is the most basic analysis, and it usually doesn't give any much information. Okay, so just by analyzing single variables, we won't find much insights related to the defaulters. As here, we will just have an idea which category of people are present in abundance. Other than that, most of the insights are gathered in analysis of multiple features or variables with target variable. Okay. So these kind of analysis we have also done, income type versus target variable. These are our findings that you can see: income type, working, commercial associate, and you can see maternity leave. These, so the working class applies the most of the loans, which is quite obvious, right? It has the most number of numbers and have a very low default rate. You can see working default rate is here. Almost 10% of the people have left, like have not paid. That means it's very less. But look at this maternity leave. So even though maternity leave number of people are less, I don't know the exact numbers, could be 500, could be 1000. It is very less, but 40% of them are not repaid because of reasons, because they might be on maternity leave or could be of some other reasons, right? So these are the insights which you start getting once you analyze multiple variables. Okay, similarly I have also analyzed occupation type versus the target variable. So low skilled laborers and lower class staff are most likely to be the loan defaulters than high skilled staff and accountants, which is understandable, right? You can see laborers, sales staff, core staff, these are having the most number of percentage of not paying the loans. Could be of multiple reasons, could be of monetary reasons, or could be of multiple reasons, right? Which is quite understandable. So better the occupation, lesser the chance of defaulting. This is the insight which we got. Okay, education type versus target. Now education type, you can see secondary has the highest, higher education second highest, then incomplete higher. Let's see which is the education type which has the most defaulters. You can see lower secondary, this category, the fourth category, lower secondary has the highest percentage of not paying the loans, defaulters. Again, which is quite understandable. I mean, not quite understandable, but yeah, this is what the data is speaking. Most student loans are for their secondary education or higher education. Lower secondary education loans are most risky for the company, followed by secondary or secondary special. I don't know the exact intuition how it is possible, but this is what the data is telling. Okay, I'm not drawing any conclusion out of it. Again, we have organization type versus target variable. You can see it's very messy because there are a lot of numbers, lot of values. Type 3, self-employed, others, these are the highest values. Transport type 3, industry type 13, industry type 3. So organizations with highest percentage of loans defaulters are transport type 3, industry type 13, and blah blah blah. You got my point, right? So these are the most defaulters. Similarly, what is the occupation type versus defaulters? So these are the analysis we need to do. If you have more number of columns, your EDA process will be it will be lengthy. If you are having less columns, you can easily do EDA in couple of days, right? So laborers, you can see male and female. So what are some good insights? Female under occupation, accountants, private service staff, secretaries, realty agents, HR staff are the most defaulted subcategories. Where are they? So laborers, accountants, where are accountants? Accountants. You can see the female ratio is very high. Okay. Cleaning staff, very high. Okay, so these are the insights which we can get. And what are the insights from male candidates? Low skilled laborers. You can see laborers are the highest defaulters. Similarly, drivers are the highest defaulters. Okay, so these are the most defaulted subcategories against their counterparts. Similarly, these kind of analysis we need to do. A lot of things are there here, like income range versus defaulters. You can see for target one, male counts are higher than female. Okay, income range from this to this is having more number of credits. Where is that? Uh, okay, male counts are higher than female. Okay, so male counts are higher. Yeah, see in the low, you can see this inside for the lower salary range, and when the candidate is male, they are having the highest default ratio, like 14% of default ratio, right? So obviously if the salary range is less, the default ratio is more, which is quite obvious. This is a very quite obvious insights, right? Similarly, all these kind of insights has been done with a lot of variables, and the entire code will be available to you for a further analysis. You can check that. And next one will be numerical analysis. Similarly, you can see age analysis. We have converted it into age ranges, and then we are analyzing it. So age range of, let's say, so you can see 20 to 30 age group are the people who are the most defaulters, right? You can see age distributions. As clients get older, they tend to repay their loans on time more often. Could be because of one reason, that they are responsible, and 20 to 30 are youth, so maybe they are very I mean they are not reluctant to pay the loans. Probably younger clients are less reliable than older clients, right? So even though the correlation is less significant, it does affect the target. Okay, this is how the age distribution is done. So all this kind of analysis has to be done. There are a lot of features here, more than 100 features to be analyzed. So that is the reason it is very complex. You can take time to go through the code, and you can reach out to me in case you have any questions. Okay, so yeah, I mean these are the insights. I'll also send you out this particular PPT so that you can understand. And yeah, PPT plus the code, I think it will clear most of your doubts. So these are our final thoughts from the entire EDA which we have done. So banks should focus more on contract type student, pensioner, and businessman with housing type other than co-op apartment for successful payments. So these are the target areas who are not paying. So bank should focus more on these target areas. Bank should focus less on income type working, because if they're working, they're more likely to pay, right? As they're having most number of unsuccessful payments. Okay. Uh, Unsuccessful or successful? I think it's a mistake. Successful payments. Okay. Also with loan purpose repair, is having higher number of unsuccessful payments. So these are all the insights which we are getting. See, laborers, sales staff, drivers seem to be the most defaulters, as we concluded earlier. Further digging into the female candidates, most of the waiters, private staff, realty agents, HR staff, IT staff, secretaries are the defaulters. I mean, I'm not targeting the HR people, but I mean, this is how the data is telling. Okay. So I think that's it. Female applicants without car are the most defaulters. So you got the idea, right? This is how your EDA has to be done. EDA has to be done in this way. We have to analyze each and every variable with each other, and numerical analysis has to be done, and that's how we get the outcome of an EDA. Okay, so that's it from today's video. It was lengthy, I know that, but I hope you get it. I will pass the code and pass the entire presentation. And next week also we are having some like seminar kind of webinars. In case you have any doubts, guys, just I'll keep the call open for next 2 minutes. Yes, yeah, Shubham was asking about the sessions. Like we often do at this time only, Sunday 8 p.m., but not every weekend, most of the weekends. But yeah, in case you are part of the community, or in case you have already subscribed to my channel, you can easily get the notifications. Okay. Next weekend class is going to be on Power BI. So let me conclude. In case you have any doubts, I'll keep the call open for 2 minutes. Thanks for joining me for the session, Shivani. The use case part was really nice, and I hope the rest of my part was informative too. Hopefully, we can collaborate for similar sessions in the future as well. And just wanted to tell something to the viewers. Some people have already dropped, which is still okay. Actually, I have recently posted about an AI data science. See, first of all, my YouTube channel is all about free courses, free webinars, free workshops. I keep doing all these stuffs. Next week also we have free webinars on Power BI. But this is something off topic I'm asking, that I recently posted about an AI data science and analytics program conducted by Bing Data. I mean, it's basically an end-to-end data analytics and data science program. Obviously, not for free, as it's an end-to-end 5 months instructor-led program with unlimited one-to-one guidance from me. In case you are interested for this program, you can fill out the Google Forms available in the description below, or else feel free to ping me on WhatsApp or LinkedIn. Even if you are not interested for these programs, I mean, you are open to join all my webinars and workshops for free. Okay. Thank you for joining this session. I also have few sessions lined up on various topics. So please subscribe to my channel to keep me motivated. Do share my videos as much as possible and like the videos. Shivani, do you like to tell something?
It was good, although I know the code was really long, and that's why it took a lot of time explaining. 2 hours
Yeah.
actually didn't do justice because EDA is a long topic. It's actually a subject
Yes.
in itself. So, if you guys
Yeah.
have any doubts, I've put up the code on my GitHub. Feel free to check that out, and it also has the link to the dataset. Although Satyajit will also be sharing the data and the code with you separately, but yeah, if you're really curious to check that out right now, you can go check out my GitHub. And apart from that, if you have any doubts, feel free to reach out to us. As he
Yeah.
mentioned, he's already put our LinkedIn profiles below. And yeah, it was really fun joining for another session. Let us know which more sessions you're interested in and what would you like to hear from us again, so that we provide what you want. And yeah, thank you for having me in here again.
Yeah,
It's
maybe
really
we
fun.
can. Yeah, we can wait for 2 more minutes and ask people if you have any specific requirements that you need session on some specific topics. Just leave something on the live chat. I'll just look at it, and accordingly I'll just finalize. So for the
I think
yeah, yeah, tell me.
Abdul has a question. He's asking like if we can use MATLAB as a tool software. Yes, you can. So you can actually perform EDA with MATLAB as well because it provides a lot of examples and applications. So MATLAB usually there's more algorithms that are inbuilt, and it also has a lot of pseudocode which you can straight away start using. So yeah, MATLAB is easier, but I will personally still stick to Python because it gives me more freedom to do the same thing.
Yes. Yeah, I mean there are a lot of analytics tool, but yeah,
Yeah.
it's a debatable topic. So debatable topic. So let's not talk about that, guys. If you have any specific requirements, you want sessions on a specific topic, uh, don't write deep learning or machine learning because it's huge. Any specific topic, let's say CNN or anything like I don't have anything in my mind. Uh, Python session. I have an entire Python playlist in my channel. There are like 17 to 18 videos. Go through that. The immediate next week will be on Power BI. So there is a guest joining in for that, Sangamesh. So I'll share all the information over the groups. In case you are not a part of the groups, probably I will force you to subscribe the channel and press the bell icon to get notified. Time series Bala, it was covered in one of the previous sessions, but I will also keep one more session for time series because it's very important. We'll have a live session on time series soon, probably in 2 weeks. Support vector machines. Okay, we can do a session on entire classification algorithms. I think that will cover the SVMs as well. Any specific doubts? Any other doubts? Okay, that's it. Thank you guys. It was nice having you all. I think this was the first webinar where we had the highest number of participants joining in. I think at some point of time I also saw 61. I was really shocked for that. Computer vision, I'll try to take that, Jagdish. But before that, are you good at deep learning? If not, I already have the videos for deep learning. CNN, ANN, all the topics are covered in depth. And yeah, we can have a basics of computer vision very soon. Shivani has already left, which is okay. I'll still be talking. Any questions? Any doubts? Anything specific to your uh, anything specific to your career or something like that? In that case, also I'm open because yeah, we created this community called as Being Datum. Have a look at our website as well, beingdatum.com. So that's basically my own community. We started with a vision of free education, and that's where I started giving all these lectures and all those things. But yeah, apart from the free stuffs, we also have some paid stuffs, but I'm not doing a marketing of that. From where we can get the raw examples to practice. So raw examples as in the raw use cases. This is one of the raw use case. I will share the code and the data sets with you so that you can practice. If you're not confident on Python, you can use the data sets and analyze on Power BI or on Tableau or on Excel. It's up to you. Jagdish, could you contact me on LinkedIn? Maybe I will be the right person to talk over there. Okay. Any other questions, guys? Still, any other questions?
Also, for the ones who were asking about machine learning and computer vision and stuff, so this is completely unrelated, but I am going to be starting a free course in collaboration with a well-known foundation from April 1. So if you're interested in the same, yeah, you can reach out to me, and I'll obviously be posting up on LinkedIn as well. And yeah, for so we'll be covering everything from the basics, so you will also get a better idea of the same.
Great. Okay, guys, 2.5 hours, very lengthy session. Thank you, guys. Thanks for joining. And yeah, let's catch up for the next week. Please have a look at my channel in case you are new. There are pretty much good stuffs there. I'm trying to put more contents as well. But yeah, managing a YouTube channel is very hectic. Thank you, guys. Thanks. Good night.
Thank you
Thank
so
you,
much.
Shivani. Thank you, Shivani. Bye bye.
And yeah, everyone, please go ahead and check out his channel. It's amazing. He's doing great stuff. So yeah, all the best and have a great day ahead.
Okay, Shivani. Bye bye. Thank you all. Thanks,
Yep.
Bala. Thanks,
Thank you.
Jagdish. Thanks,
Thanks.
Jeffrey. Thank you, everyone. Thanks, Ranvijay. Bye bye.